When the most potent space telescope ever created began spying on planets that circle other stars last month, it signaled the beginning of a new chapter in the quest for extraterrestrial life. The James Webb Space Telescope is expected to uncover whether some of those planets have potentially habitable atmospheres. Hey people, welcome back to our channel. In today's video, we'll be looking into the latest discovery of the James Webb Telescope. Before we start, make sure to subscribe to our channel, turn on the notifications, and most importantly, watch the video to the end. Let's get started. It'd be amazing enough to find an atmosphere in another solar system. Even yet, there's a slim possibility that one of these atmospheres will contain what is known as a biosignature, or a trace of life itself. Megan Mansfield, an astronomer at the University of Arizona, predicted that humanity would be able to discover planets that intrigue us and perhaps harbor life. However, we won't always be able to spot life right away. The only planet in the cosmos where life has been discovered so far is Earth. Despite over 60 years of sending probes to Mars, no Martians have been discovered. However, it's conceivable that life could be hiding beneath the surface of the red planet or on a moon of Jupiter or Saturn, waiting to be found. Some scientists have maintained that Venus might harbor Venusians despite its burning environment of sulfur dioxide clouds. Even if Earth ends up being the sole planet with life in our solar system, there are many more solar systems in the cosmos that include planets that are classified as exoplanets. The first exoplanet orbiting a sun-like star was discovered by Swiss scientists in 1995, the exoplanet 51 Pegasi b, which is bigger than Jupiter and has a surface temperature of 1800 degrees Fahrenheit, proved to be an unfavorable place for life to exist. Since then, more than 5,000 more exoplanets have been discovered by scientists. Some of them are much more like Earth. They're nearly the same size, composed of rock rather than gas, and they orbit in a region known as the Goldilocks zone around their star, where they're neither too close nor too far to either get roasted or frozen. Unfortunately, these exoplanets have been increasingly challenging to investigate up until now because to their small size. This will change with the advent of the James Webb Space Telescope, which will serve as a magnifying glass for astronomers to examine these planets more closely. The telescope has traveled 1 million miles from Earth since its launch from Kourou, French Guiana, and has now entered its own orbit around the Sun. Its 21-foot mirror is shielded there from the Sun's and Earth's heat and light. The telescope can pick up weak, far-off glimmers of light, including those that can provide new information about distant planets, even in this extreme darkness. According to Dr. Mansfield, the Space Telescope is the first major space observatory to take the study of exoplanet atmospheres into account in its design. Midway through June, NASA scientists started using the Webb telescope to capture images of a variety of objects. On July 12th, the public will be able to view the Webb telescope's initial images. According to principal scientist for the initiative, Eric Smith, the initial collection of images will include exoplanets. Dr. Smith viewed those initial images as a quick and dirty assessment of the telescope's capability because the telescope will spend only a brief amount of time observing the exoplanets. Following those brief glances, a series of lengthier observations will begin in July and provide a much clearer image of the exoplanets. The 7 planets that circle the TRAPPIST-1 star will be studied by a number of astronomy teams. 3 of the planets may be in the habitable zone, based on earlier observations. The TRAPPIST-1 planets will be observed beginning around July 4th, and Olivia Lim, a PhD student at the University of Montreal, remarked that this is a great area to seek for indications of life outside of the solar system. The habitable zone of TRAPPIST-1 is closer to the star than that of our own solar system since it's a tiny cold star. Because of this, the star's possibly habitable planets orbit close by and complete one full rotation in just a few days. Scientists will be able to answer a simple but important question every time a planet passes in front of TRAPPIST-1. Do any of them have an atmosphere? Nicole Lewis, an astronomer at Cornell University, stated that even if a place is in the habitable zone, it's not habitable if it lacks air. The lack of atmospheres encircling the planets of TRAPPIST-1 would not surprise Dr. Lewis and other scientists. Even if the planets had atmospheres when they first formed, ultraviolet and X-ray radiation from the star may have long since destroyed them. The possibility exists that a planet's whole atmosphere may be removed before life could even begin to exist there, according to Dr. Mansfield. Whether these planets could have an atmosphere long enough that they'd be able to create life is the first-order question that we're attempting to answer. A planet passing in front of TRAPPIST-1 will generate a tiny shadow, but the shadow will be too small for the space telescope to catch. Instead, a little attenuation in the star's light's path will be seen by the telescope. According to Jacob Lustig Jaeger, an astronomer working at the postdoctoral fellowship at the Johns Hopkins Applied Physics Laboratory, it's like looking at a solar eclipse with your eyes shut. You might have noticed a change in the brightness of the room. A planet having an atmosphere would affect how the star behind it dims in a different way than one with no atmosphere. Some of the star's light will enter the atmosphere directly, but certain wavelengths of light will be absorbed by the gases. The planet will further dull TRAPPIST-1 if observers focus entirely on starlight at those wavelengths. These observations of TRAPPIST-1 will be transmitted back to Earth by the telescope. Then you receive an email saying something like, "Hello, your data is available," according to Dr. Mansfield. However, TRAPPIST-1's lights will be so dim that it'll take some time to interpret it. Your eye is accustomed to handling millions of photons each second, according to Dr. Smith, but these telescopes are only gathering a small number of photons every second. Dr. Mansfield and her team astronomers will first need to separate exoplanets from minute oscillations created by the telescope's own equipment before they can investigate exoplanets that are passing in front of TRAPPIST-1. In order to see the teeny tiny signals, Dr. Mansfield said, "A lot of the work that I actually do is making sure that we're properly correcting for anything unusual that the telescope is doing." Dr. Mansfield and her co-workers might find an atmosphere surrounding a TRAPPIST-1 planet as a result of their research. But that outcome by itself won't show what the mood is like. It might have a high nitrogen and oxygen content, similar to Earth. Or it might be more like Venus's poisonous stew of carbon dioxide and sulfuric acid. Or it might be a combination that researchers haven't seen before. Alexander Rath, an astronomer at the Technical University of Denmark, stated, "We have no notion what the composition of these atmospheres is. We have theories, simulations, and other things, but we truly don't know. We must go and check." Because each type of molecule absorbs light at a particular spectrum of wavelengths, the James Webb Space Telescope, also known as the JWST, may prove to be powerful enough to identify the precise components of exoplanet atmospheres. However, those discoveries will be influenced by the exoplanet's weather. Any attempt to locate alien air could be foiled by a dazzling, reflective layer of clouds that blocks all starlight from entering an exoplanet's atmosphere. Dr. Rath observed that it was difficult to tell the difference between an atmosphere with clouds and one without. Astronomers are especially interested to determine whether the exoplanets' atmospheres contain water if the weather is cooperative. On Earth, at least, water is a necessity for biology, Dr. Mansfield stated. "We believe that would probably be an excellent beginning point to look for life. However, a liquid atmosphere does not imply that an exoplanet is home to life. Scientists will need to find a biosignature, which is a molecule or a combination of compounds that is uniquely produced by living things, in order to be certain that a planet is alive. What would constitute a trustworthy biosignature is still up for debate among scientists." With that, the video has come to an end. Let us know what you think in the comment section to help us expand our community and attract more people who share our interests and are eager to learn. Please hit the like button and subscribe if you thought the video was interesting. Till then, bye.